Welcome to today's lecture. This is Photoelectricity Part 3. In Part 2, we looked at the differences between the classical wave theory and the particle nature of light. We summarized that in the classical wave theory, light energy is continuous. However, for the particle wave theory, we said light energy is quantized. That is, light energy is emitted in a discrete unit separate packet. That is, the emission of light is not continuous. We also said that light energy depends on frequency, on the particle nature of light. However, the intensity of light determines its energy in classical wave theory. Today we'll be looking at photocell. Photocell. A photocell is a device that uses photoelectric effect to convert light energy into electrical energy. The brief construction of photocell. A photocell consists of a glass or vacuum tube. Number 2, a photosensitive cathode, usually cesium, potassium, or sodium. Number 3, an anode collector. And lastly, an external unit. The diagram below shows a schematic view of a photocell. This is the glass or vacuum tube, the vacuum. This is the evacuated glass. The collector, that is the anode. Of course, the glass, evacuated glass, collects the UV light, that is ultraviolet rays, which eventually causes photoelectrons to be ejected from the cathode. Remember, the cathode is the photosensitive part of the photocell, usually made up of potassium, sodium, or cesium. And then we have the ejected electrons, that is the photoelectrons, when the cathode absorbs the UV rays. We need to note certain things, that the emission of electron is dependent on the frequency or wavelength of the incident radiation. That is, the emission of these photoelectrons depends on the frequency or wavelength of the UV rays. Number 2, the maximum kinetic energy of the emitted electrons is dependent on the frequency or wavelength of the incident radiation. Number 3, the number of photoelectron is dependent on the intensity of the incident radiation. Briefly, let's look at the working principle of a photocell. The mode of operation of the photocell. Light falls on the photosensitive cathode that is made up of either potassium, sodium, or cesium. Number 2, if the frequency of light is greater than the threshold frequency, electrons are emitted. The emitted electrons move towards the anode. This movement of electrons produces an electric current. A quick summary again. Light falls on the photosensitive part of the photocell called the cathode. If the frequency of the light is greater than the threshold frequency, then electrons are emitted. The emitted electrons move towards the anode. This movement produces electric. This will take us to stopping potential in a photocell. Stopping potential. Stopping potential comes up during the measurement of the kinetic energy of photoelectrons in a photocell. Where exactly does it appear? A variable reverse voltage is applied between the anode and the cathode of the photocell. The anode is made negative with respect to the cathode. This reverse voltage opposes the motion of the emitted electrons. Meaning of stopping potential. The stopping potential is the minimum reverse potential that just prevents the fastest, that's most energetic photoelectrons from reaching the anode. The stopping potential is the minimum reverse potential that attempts to prevent the most energetic photoelectrons from reaching the anode. At this voltage, that is at the reverse voltage, photocurrent becomes zero. Even the most energetic electrons are stopped. What's the connection between stopping potential and the Einstein's photoelectric equation? So let's see it. At stopping potential, EK max is EVS. E there is the electron charge. Vs is the stopping potential. So half mv squared is EVS. Don't forget half mv squared is E minus W naught. So EVS is HF minus HF naught. We need to commit this formula to memory. We have taken a whole lot of formula. To take your time to commit these formulas to memory. Importance of stopping potential. It is used to determine the maximum kinetic energy of photoelectrons. Number two, it confirms that electrons' energy depends on the frequency, not intensity. It confirms that electron energy depends on frequency and not intensity. What are the applications of a photocell? Number one, it is used in automatic street lights. It is used in burglar alarms. It is used in counting systems. It is used in automatic doors and camera light meters. That is, even in television camera, it finds application there. So these are the applications of a photocell. Number one, automatic street lights. Number two, burglar alarms. Number three, counting systems. Number four, automatic doors. Number 5, camera light system, and also in TV cameras. I'll see you in part 4.